Good morning, dear students. I hope you are doing well and preparing for your CIEs and preparing for your papers. Right now, we are again here with some very interesting question of momentum. Sorry, of torque, basically. Right now, you can see in the question that it is a uniform being pivoted at the point. Two weights 10 and 20 Newton are attached to its end. Length of the beam is 0.1. Length of the beam is marked at 0.1 meters. It means this is marked at 0.1. Each if you split it out, then each of this part is 0.1. It is again 0.1. This one is again 0.1 and it is again 0.1. Okay, so these are the pieces of 0.1 attached all together to form a beam of approximately this is to overall 1 meter. Okay, though this is 0.6 and 0.4, it means the whole length of the beam is 1 meters. Okay, you are getting my point. Okay, the weight of the beam is 100 Newton. Okay, so you know that weight of the beam is basically is always we take towards the center of the gravity, that is towards the center of the object. It means if you count what will be center point 1 2 3 4 and 5. Okay, so this will be the center point. Here the weight will be appear to act, that is the weight is 100 Newton. Okay, its weight is always downward. So right now you see that weight is acting downward, and also now they are asking that at which point should further weight of 20 Newton be attached to achieve equilibrium. So right now you see that the pivot point is not also at the center, plus the weights are not evenly distributed. Here you see on the left of the pivot you see two weights, that is 100 and 10 Newton. On the right hand side you see it is 20 Newton. So the rod is not equilibrium. We need to find some equilibrium possibility, and we have to add another weight of 20 Newton. Okay, so okay, basically in order to make this uniform beam in equilibrium, we know that anti-clockwise torque equal to clockwise torque. Okay, so right now you see that these forces, this 20 Newton forces is moving this rod in this direction. It means 20 Newton force is where it is clockwise, and this 10 Newton force pivot on the left hand side of the pivot, it is forcing this beam, uniform beam, on the anti-clockwise direction. Okay, so we will term this as 10 Newton force, the anti-clockwise torque it is providing to this rod, uniform beam. Okay, so we need to find and we need to suggest somehow that where the torque is greater, and we need to balance that. Where the torque is lesser, so we need to balance that. Okay, where the torque is less, we will add some torque into that direction. For anti-clockwise torque, we will find out using this weight, that is 100 Newton of the beam, and using this 10 Newton force, because these are both on the left hand side of the pivot, so these will rotate this beam anti-clockwise. Okay, so right now pivot is here, and you will see that from the pivot the 10 Newton distance is 0.6. it is given 0.6. Okay, so 10 and 0.6, so 10 is the force anti-clockwise, plus the pivot distance from 10 Newton from the pivot is 0.6, so it will be 0.6 plus the weight of the beam is also acting as anticlockwise torque, so this will be 100 multiplied by pivot is at 0.6. okay, so 100 for the distance between the pivot and the weight force 100 Newton is 0.1. okay, so we will write as 0.1. okay, and for the clockwise torque we have this 20 Newton force. 20 Newton force from the pivot is 0.4 distance. okay, so right now you will see that 20 Newton force at a distance of 0.4. so just calculate it and you will get that here you will get 16 and here you will get 8 on the right hand side. It means that 8 is the clockwise torque, so it means this is lesser and we need to add some weight on the clockwise side. It means on the right hand side of the pivot something has to be added on the right hand side of pivot, but where at what point we need to add the force, we will find it now. okay, now this will be 16. Left hand side will remain same because it is greater, anti-clockwise torque is greater, so we need to just balance the clockwise torque. okay, so on the right hand side it will be 8 plus, and right now they've already said that we need to attach the 20 Newton force to achieve equilibrium. okay, 20 Newton weight to achieve equilibrium. This will be the 20 Newton weight to achieve equilibrium, but at what point we don't know. So torque is F into X, so this 20 Newton weight will be F into X. This X point we don't know. okay, we are balancing this on the clockwise direction. okay, so because here the clockwise direction the weight is lesser, so just manipulate it. You get 16 minus A is 8. This is 20x, and when you find out x, it will be 0.4. okay, so it means this 0.4 means you add weight of 20 Newton at 0.4 distance from the pivot, means from P, at 0.4 distance from P. okay, so right now you see that pivot is here, the position is here, and from on the right hand side of right hand if you travel 0.4 from P towards the right, you will get 0.1, 0.2, 0.3 and 0.4. it means you will attach the weight at point D towards it means 0.4 units from pivot point P. so the right option is D. okay, so the correct option is D will be the correct option, because D is 0.4 units away from the pivot. okay, hope you will getting my point.